This chapter covers Extrema, that is minima and maxima, which are one of the patterns recognized by Trading Conceiver. In particular, when the pattern is matched and what we mean by asymmetrical extrema. To view the implemented extrema patterns, in the Composer tab select the branch Patterns. We consider minima and maxima as relative, non-strict extrema. We use the low price to determine minima and the high price for maxima. A minimum occurs when the low price is lower than or equal to the low of its neighbors. A maximum occurs when the high price is higher than or equal to the high of its neighbors. The neighbors, bars in this case, are on the left and on the right side, and how many of them to consider is determined by the radius, the input parameter. For instance, this is a minimum with radius 2. It means we consider the two bars on the left and the two bars on the right and look at the low price. As the low price is less than the other bars under consideration, the K-bar is a minimum. The same holds for the maximum with radius 2. We consider the two bars on the left and the two bars on the right and look at the high price. As the high price is greater than the other bars under consideration, the K-bar is a maximum. We now focus on maxima. The same holds true for minima. Note that we accept the fact that the maximum can also be equal to and not necessarily only greater than its neighbors. Hence it is not a strict maximum. This is to assure to detect situations where we would expect a pattern to be recognized. For instance, this case. The bars marked with an M have equal high price and they are both considered maxima and matched as such. Note that, in this way, less intuitive formations are considered maxima, like this one, with radius 2. Again, both bars marked with M are considered maxima. By changing the input parameter radius, different extrema are found. With a greater radius, less points are detected. In the picture, we can see the effect of selecting two different radii for finding maxima, radius 1 and radius 3. In both cases, the bars highlighted in blue are found. The bars highlighted in yellow are found only with a smaller value. It's apparent that if you want to find prominent extrema, you need to select a big radius. If on the contrary you want to detect even small corrections, you need to select a small radius. As always with pattern matching, the pattern is matched at the very last bar of the pattern. That is where the pattern is complete. It is not matched where the extremum is, so it doesn't indicate where the extrema are. As explained in the previous chapter, in Trading Conceiver the bar when the pattern is matched is labeled N. This is the last bar of the pattern. Previous bars in the pattern are labeled N-1, N-2 and so on. This counting highlights the fact that to match a pattern you have to look into the past, not into the future, and you can say a pattern is found only at the very last bar. With this kind of notation, the previous example looks like this. Pattern is matched on day n, not n-2. When used in the Composer, this trading algorithm will correctly be true on day n, not n-2. If it were true at the extremum bar, n-2, it would be predictive, as if it could look into the future and know from the past that this will be recognized as being an extremum. You would be trading with foresight and clairvoyance. You know that n-2 was an extremum only at bar n, not before. On bar n-2 you have to wait 2 more bars in order to know whether that was an extremum. Let's make an example with a minima algorithm with a radius of 3. The algorithm is true 3 bars after the minimum. For instance, this signal refers to this bar. This other signal refers to this other bar. This bar is not a minimum because its low is not the lowest among the 3 bars on the left and on the right. With maxima and minima, as explained above, in order to find prominent extrema, a radius greater than 1 should be used. The greater the radius, the more prominent the extrema. However, the greater the radius, the more delayed the signal is, because the signal is true only at the last bar of the pattern. If the radius is big, the signal is given after a lot of bars after the extremum, and it risks to be too late to be useful. In order to compensate for this, we introduce asymmetrical extrema, where the user can select different radii for the left and the right side of the interval. By selecting a big number for the left radius and a small number for the right radius, a compromise between identifying conspicuous extrema and not waiting too long can be achieved. Let's look at the example pictured here, where the pattern matching for 3 selections or radii are represented in the order: Case 1, symmetrical radius equal to 1. Case 2, symmetrical radius equal to 3. Case 3, asymmetrical radius, radius left equal to 3, radius right equal to 1. Clearly, the occurrences of 1 are more numerous than both of the others. The occurrences of 2 are less numerous than both of the others. The occurrences of 3 are somewhere in between. The notable maximum M1 is detected by all 3, but in 2 it comes 2 bars later. The maximum M2 is detected only by 1, not a conspicuous maximum, but definitely useful as a correction. The maximum M3 is detected only by 1 and 3, but not by 2. Indeed, its prominence is something in the middle between those of M1 and M2.